Hello students, today we are going to learn how to multiply two matrices, and after that we are going to learn how to find the inverse of any matrix with the help of elementary transformation. Okay, so today we are starting with multiplication of two matrices. Here, suppose a matrix is A with order m cross n and any other matrices with order n cross p. If you need to multiply both of the matrix, we get any other third matrix, that is C. And the order of C is always represent the first element for this and second for this. So the order for C is n cross p. This is the order for the resultant matrix. But before multiplication, we need to remember one thing, that the column of first matrix and the number of rows for second matrix is always equal. Then only we are able to multiply these matrices. If these are not equal, then we clearly say the multiplication does not exist for the given matrices. It is compulsory that the column part for first matrix and the number of rows of second matrix is always equal with each other. And in multiplication, A cross A into B is not equals to B cross A. Means it is not compulsory in every case that A cross B is equals to B cross A. It is not compulsory. It may be equal or it may not be equal, but it is not compulsory. Clear? So we can say AB is not equals to B. Now we are going to learn that how to multiply these two matrices. Suppose a matrix A with element 1, 2, 8, 7 and a matrix B with element 6, 3, 4, 5. Now we need to find the value of A into B. A into B. 1, 2, 8, 7, that is 6, 3, 4, 5. You need to multiply. Here it consists 2 by 2 order. It contains 2 by 2 order. It means resulting matrix contains 2 by 2 order. The elements for this A11, A12, A21, A22. If we find the value of A11, A12, A21 and A22, then we can get the value of AB. Okay. Now for A11 means first row for A and first column for B. Clear? It represents first row and first column. Means first row for A and first column for B. The product of these two can give the value for A11. Then 1 into 6, that is 6, plus 4 into 2, that is. Similarly, for the second term, A12 means first row, second column. This is the first row and this is the second column. If we are going to multiply this, that is 3 ones are 3 plus 5 twos are 10. Clear? Now, similarly, moving further, that is A21 means second row, first column. Here it is this second row and it will multiple with first column. Means 8 into 6, 8 6 are 48 plus 7 4 are 28. Similarly, A22 means second row and second column. Then 8 3 are 24 plus 35. So if we solve this, 8 plus 6, that is 14, 13, 60, 76 and it is 59. So this is the required answer. Clear? Okay, we will take one more example. Suppose A is given 1, 2, 3 and B is given 4, 5, 6. Here we need to find the value of AB and B. This is the question. Here in this question you need to find the value of A into B and B into A. By this we can check why these are not equal. Okay. So first of all we need to find the order for this. It is 3 cross 1 and it is 1 cross 3. When we do AB means 3 cross 1 into 1 cross 3, we will get the matrix of 3 by 3. 3 by 3 means A11, A12, A13, A21, A22, A23, and A31, A32, and A33. Okay, A11, first row with first column. Here it is first row and here it is first column. It will multiply, then 1 into 4, it gives 4. 1 into 5, 5. 1 into 6, 6. Now 2 into 4, 8. 2 into 5, 10. 2 into 6, 12. Similarly, 3 into 4, 12. 3 into 5, 15. 3 into 6, 18. So this is the required answer. Clear? Now, if we move further for find the value of B cross B into A, then for B into A. B into A means if B into multiply B means 1 cross 3 and A means 3 cross 1. Here both the elements are same, so multiplication is possible and the resultant matrix is 1 by 1. Okay, now solve. 1 by 1 means A11 is A11 means first row and first column. First row for A. Here it already consists only one row, that is 4, 5, 6. Okay, before multiplying this we can write 4, 5, 6 and the multiplication of 1, 2, 3. Now we can clearly observe the first row for this and the first column for this. Multiply 4 into 1, 4 plus 5 2 is 10 plus 6 3 is 80. So when we add this, we get 28 plus 4, that is 32, and this is the required answer. And here we can clearly say AB is not equals to PA. Okay, so this is the overall concept for multiplication of two matrices. I hope this is clear to all of you. Now please pause the video to note it down. Okay, now moving towards this topic, inverse of matrix by elementary transformation. Elementary transformation will be done by two ways, either with the help of row or by column. Okay, here we need to find the inverse. Why inverse is needed? Because if someone is given A into B equals to C and asks find the value of B, then what we can do? We simply transpose this A, and we are not able to divide any matrix. Then what we can do? We can just simply took this A in our portion, in numerator part. Then we can write A into A, C into A inverse. So for this we need to find the inverse of any matrix. If we find the inverse of the matrix A, then we can simply multiply A and C and we will get the value for B. Clear? Now we are going to understand this method with the help of an example. Suppose a matrix is given, that is A 2, 5, 1, 3. Here we need to find the inverse of this matrix. We know very well when we multiply any matrix with its inverse, we can find a unit matrix, and here unit matrix is represented by I. Substitute all the values. Here we know the value of A, that is 2, 5, 1, 3. A inverse is unknown, here we need to find, and the value of I is 1, 0, 0, 1. Clear? Now our target is just convert this diagonal element as 1 and rest all the elements will be 0. We only need to focus on this part. We just convert this as a identity function and it will be automatically convert their RHS part as well. Now convert these terms as 0 and these terms as 1. This is our basic target. Here we are using row transformation, so we can subtract any row. Means initially हम आपस में किसी भी रो को किसी से भी प्लस या माइनस कर सकते हैं, बस हमें इनको 1 बनाना है और इनको 0. Okay, so our basic target to convert these term as a 0. This will become 1 in a very easy manner. We can just simply divide the number which are available at these places. Okay. Whatever be the transformation you are going to apply on LHS side, then same transformation is going to be applied in RHS side as well. Clear? Okay. First of all, we need to convert this 1 as a 0. So when it will be 0, if it will become 2 and it will subtract with, it is R1, it is R2. If it will become 2, means R2 changes to. It will become 2 means this will become 2R2. Now subtract. If we need to convert this as a 0. If 2 will subtract with 2, then it will become 0. Then R2 minus. Now apply. There we are going to change in R2. So there is no change in R1. Clear? Now 2R2. 2 into 1, that is 2. 2 minus 2, 0. 2 into 3, 6. 6 minus 5, that is 5. Here it is. Now, the same transformation is going to apply on this RHS part. There is no change on first row. Now, in second row, 2 into 0, that is 0. 0 minus 1, minus 1. 2 into 1, 2. 2 minus 0. Clear? Now, this term is already 0. Now we need to convert this 5 as a 0. Here it is 5, it is 1. If we multiply 5 in this term and subtract by this, then it will become 0. So what we can write, R1 changes to R1 minus 5 times of. Okay, one thing you always have to remember that if R1 has to change, then first R1 will be written here. Then only you need to subtract or add any of the row with this R1. Clear? You have to follow only one elementary transformation, either for rows or for column. You can't mess up both the transformations. Clear? Now apply this. Here there is no change with R2, so we can write R2 as it is. Now R1 2 minus 5 into 0, that is 2. 5 minus 5 into 1, that is 0. In the same way with RHS, 1 minus plus 5, 1 plus 5, that is 6. 0 plus 5 to the 0 minus 10, that is minus 10, and minus 1 and 2. What was the target? Convert this and this term as a 0. the target will complete it. Now, what was the second target? Convert this as 1. It is already 1. We need to convert this as a 1. We just simply divide R1 with 2. We can convert R1 changes to R1 by 2. Now apply this. We get 1 0 0 1 equals to A inverse, that is 3 minus 5 minus 1 and 2. It is clear to all of you? Now this denotes an identity function. Identity function means 1. When any identity function with multiplied with any of the terms, then we will get A inverse, and the value of A inverse is 3 minus 5 minus 1 and 2, and this is the required answer for the given question. I hope it is clear to all of you. Now please pause the video to note it down. Here in this question, A matrix is given and we need to find A inverse. Okay, with the same method we are going to solve this question as well. First of all, we can write A into A inverse equals to I. Okay, now substitute the value of A, that is 1 3 3 1 4 3 and 1 3 4, and A inverse is as it is, and I is 1 0 0 0 1 0, that is 0 0 1. Okay, clear? Now we need to first of all we need to set our target. This is our diagonal. Now we need to convert or rest all the values into 0. First this, then this, then this. First we need to convert these three values 0. After that we are going to convert these values in 0. Okay, so now when we need to convert this one as a 0, if we subtract 1 from this one, we get 0. So we can write R2 changes to R2 minus R1. Similarly, we can write R3 minus R1. So here we can apply one more transformation, that is R3 changes to R3 minus R1. Now apply. So we get, there is no change in R1, we can write R1 as it is. Now R2 minus R1, that is 1 minus 1, 0. 4 minus 3, 1. 3 minus 3, 0. Again R3 minus R1, 1 minus 1, 0. 3 minus 3, 0. 4 minus 3, 1. And in the same way, the same property applies here. There is no change with first row. Now second row subtract from first. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. 0 minus 1, minus 1. 0 minus 0, 0. 1 minus 0, 1. Okay, this target was achieved. Already these terms will become 0, this will become 1. Now we need to convert these two terms into 0. Now here it is 1, it is 3. If we multiply 3 in R2 and subtract it from R1, so we can say R1 changes to R1 minus 3 R2. So what we get? There is no change with there is no change with R2 and R3, so we can write as it is. Now R1 minus 3 into 0. So 1 minus 3 into 0, that is 1. 3 minus 3, that is 0. 3 minus 0, 3. It is A inverse equals to. Now apply the same thing here. There is no change in second and third row, so we can write it as it is. Now for first row, R1 minus 3R2, R1 1 minus 3. So 1 plus 3, that is 4. 0 minus 3, that is minus 3. 0 minus 0, that is 0. Clear? Now our last target is we need to convert this 3 into 0. Here it is 1 and it is 3. So we can simply say R1 changes to R1 minus 3 times of R3, and this is the final transformation 0 1 0 0 0 1. Now 0 minus 0, sorry 0 minus 1 1, 0 minus 0 0, 1 minus, sorry 3 minus 3, that is 0. We can write in R1 4 minus 3, so 4 plus 3 7, minus 3 minus 0, that is minus 3, 0 minus 3, that is minus 1 1 0 minus 1 0. Here it shows an identity matrix, so we can say A inverse is equals to 7 minus 3 minus 3 minus 1 1 1, so 0 minus 1 0, and this is our required inverse of the given 3 by 3 matrix. I hope it is clear to all of you. Now that's all from my side. We will continue for some questions related to these topics which we have covered in these two videos. It will be available in next video. That's all. Thank you.